Hello everyone, welcome to Crazy Geeks and it's me Roshan Shrestha. On today's session we'll be talking about one of the interesting feature of object-oriented programming. Among the four pillars of object-oriented programming, it's one among those. One is abstraction. Abstraction generally implies hiding the complex calculations or hiding the complexities. That is, you're supposed to provide or expose the essential information to the outside domain or to the outside world. In the meantime, you are supposed to hide the details. That is termed as abstraction. Regarding abstraction, what we intend to do is we'll be normally handling the certain calculations, but the user on that part won't be subjected towards the complexity associated with those calculations or those operations. For instance, when I navigate to settings, my only concern will be getting these options. I don't have any business regarding what's going behind the scene. That is how abstraction works. When I press upon the option compiler, I will be provided with these options. I won't be having any interest regarding how these are being provided. So I will be getting rid of these complexities. This is somehow related with the concept of abstraction. As told earlier, it's one among the four pillars of object-oriented programming. Abstraction in C++ is normally carried out in two ways, one being the control abstraction and another one being data abstraction. Control abstraction normally revolves around the use of the functions, those especially related with lambda expressions and higher order functions that comes under the control abstraction. In case of data abstraction is a really fascinating characteristic of object-oriented programming. It is handled especially using the use of the header files as well as it's handled in cool operas using classes. Uh, let's write the program for the abstraction. Okay, let me comment these stuffs. Under data abstraction, there is use of the header files. Let's say we need to calculate the power of some numbers. Let's say we are supposed to find the square or cube of any number. Let's take use input, enter any number, scene number. Then at this point, I need to find the let's say square of this particular number. For that, I'm going to use math.s header file. Now, courtesy to this particular header file, I'm going to calculate the square. Cout, okay, square of what this number is. Now I will be making a function call to the standard function that is defined inside math.s. That will be POW. Okay, it requires double, so I'm going to change it to float. POW, then let's say the entered number whose power will be 2. Let's execute this one. Enter any number. Square of 3 is 9. 9 square of 9 is 81. Okay, good. Here, when we look upon this particular POW function, that is related with the power number, power 2. There is certain operations or complex calculations that is going on within the definition or body of this particular POW function. But we don't need to worry about that. This is related with abstraction, which has been achieved using this particular header file. Similar will be the scenario if we are supposed to find the square root. Let's try that as well, which is pretty much similar. Square root of this particular number is going to be what? SQRT, I guess. Yeah, SQRT number. In this case as well, we don't need to worry about what's exactly going on within the area of SQRT function. That is how this particular calculation is being carried out or is being handled. What we want is we need to find the square in this case and square root of that particular entered number in this one. That is abstraction. We are only getting the impression, or let's say access to SQRT function, but we are not subject to the complexities related with this particular operation. That is in fact is the whole concept behind abstraction. Oh, SQRT is not working. I don't know why. Let me again try it. SQRT, then there should be finding the square root of that particular number. I guess it should work fine. Oh, due to this one. Okay. Now let's execute this one. 9. The square of this particular number 9 should be 81 and square root should be 3. Okay, good. This is how abstraction is achieved using header files. Similarly, abstraction could be implemented using the concept of classes as well. And whenever we are talking about the use of the classes for the purpose of abstraction, there is going to be the use of the access specifiers or modifiers for abstraction. We'll be playing around with access specifiers, private, public, and protected. For the demonstration purpose, we'll be using private and public. Okay, quickly let's write a definition for some class. Okay, let's say we need to find the area of some shape, or let's say some rectangle for now. Area calculation is going to be the name of the class. Now within this particular area will be populating the data members and member function. Private and public are going to be the access specifiers. Here within the private scope, I'll be writing int a, l, and b. Under public, what I will be doing is I'll be writing a method for taking the input from the user. Set input int length and int breadth. You will be assigned the value being passed by the user that is going to be stored at length, and b will be assigned the value of breadth. Now on another method, calculate, what we'll be doing is we'll be this will be better for L. Now for the area calculation, A equals product of L and B. Let's say let's return this one. Return A. Wait, obviously can't return. Return type will be integer type. Now from the main block, we'll be making an instance of class area calculation AC1. Now AC1 times, not times AC1 dot, that is when we are going to access the set input method and passing some numbers. Let's say the length and breadth in this case is going to be 12 and 13. Here we don't need to worry about what exactly goes inside this particular block that is inside the class. We don't need to worry about that. We'll be just passing the input, that is value for length and breadth. Then we'll be saying I need area of rectangle is the value returned by the method calculate. AC1 dot calculate. This is how abstraction works. We don't need to worry about what exactly goes inside that particular block. That is, we are not supposed to worry about the exact mechanism or complexities that are going inside that particular method in this part. That is abstraction in general, which means you don't need to expose everything. You'll be hiding the complexities, and you'll be normally making some function calls or activating the process. Another block is going to handle that. That is the beauty of the abstraction. And in this case, L and B are not accessible from the outside. For instance, if we try to access L, then some error would be generated, obviously, because it's within the private scope. So this is how abstraction is handled. In case of lambda expression, lambda expressions or those functions are anonymous function. That is, you don't need to provide any name to those functions. These are especially the features of the C++ 14. I'll be covering the concept related with lambda in the upcoming videos, but for now, I believe you guys have some ideas regarding how the abstraction is implemented and how it works. This one is one of the pillars among 4 pillars. We'll be talking about remaining stuff in our next video. Till then, Have a nice time ahead. Thank you very much.